All right, today we're going to be talking about section 5.3, part 2. So we're just going to continue solving trig equations. So hopefully at this point you've got a pretty good understanding of sort of the general algebra that goes along with solving trig equations and what it's being asked for when it's asking for all answers or between 0 and 2 pi. Long story short, hopefully you've made some good progress in the assignment before we jump into this. All right, so to get started, I'd like us to consider this problem. Example number 3 is continuing from yesterday. What is wrong with the way this has been solved? So I'm going to take a look at this, see if you can come up with something and maybe a way to explain it to someone who doesn't see it. And a student class actually had the perfect analogy to this, even without my prompting, is exactly what I would have said. They said, well, consider how you were supposed to solve, say, the problem x squared equals x. We certainly could divide both sides by x, which is what this person has basically done, and get an answer of x equals 1. And x equals 1 is clearly an answer. If I plug in 1 to the original 1 squared equals 1, that works. So what's wrong with this approach? And the answer is, by dividing by x, we've actually thrown away one of my answers. And that is because the way we should answer this is by factoring, because this is a quadratic. So instead of dividing by x, I should move the x to the other side, giving me this, and then I can see that I can factor x out, giving me x times x minus 1 equals 0. Therefore, x equals 0, and x equals 1. X minus 1 equals 0, and we solve. So there were two answers. We got this answer, but we lost an answer. So that is exactly what has happened here, is the person, the way they've solved it is they have lost an answer. So part B on this is just let's do it correctly. So I'm just going to work it up here because it'll just be easier to see. So I'm instead going to move everything to one side. And then I'm going to factor sine of x out of each term. Now that it's factored, I can set them both equal to 0. And therefore, x equals the arc sine of 0. And move the 1 over. X equals the arc sine of 1. So now when I go to look at the answers, I'm going to go think about a circle. I'm going to put all the answers one time around on the circle. So where is sine 1? Sine is going to be 1 only when the y value is 1, so that's pi over 2. When is arc sine 0? So what angle has a sine of 0? That would be here and here. There really is no good way without maybe spending lots and lots of time analyzing this, and I'm still not sure we'd come up with anything, of writing this in one statement. So I think on this one, we're really set. We're going to be stuck writing just two statements, and one of them has already been given to us. So the answer of pi over 2, and then add a circle, both positive and negative. Why don't we have a plus minus? Because the n can be an integer, and integers can be negative. So when n is negative 1, it automatically subtracts it for us. So this is our answer to all of the coterminal angles to pi over 2. And now we just need to say another statement that x is equal to, I would say 0, and then add pi, and then add pi, and add pi. And so in this one, I'd put 0 plus, but then I'd quickly realize, well, in a minute, I probably don't need that 0. So 0 plus pi n for all n's that belong to the set of integers, right? So, but what happens if I just erase the 0 instead? Now when n is 0, I get the 0. When n is 1, I get pi, 2 pi, 3 pi. And so this would be my answer. All right. So today what we're going to be looking at primarily are questions like these. I think we're going to do 3 examples. Actually, there might be a few more. Um, so this time, notice we have sine of 3x instead of like on the others where it might have, they all were sine of just x inside. So now it's sine of 3x. So what I want us to think about before we dive into this too far is what is the difference between sine of x and sine of 3x? And the easiest way I think to analyze this is by quickly looking at the graph. So if we look at the graph of y equals sine of x, we know, let's go 1, 2, 3, 4, try to equally space them. So there's 2 pi. So we know that sine looks like this. All right, so that's what sine looks like. So what does sine of 3x look like? Well, we know, based on our rules on for graphing, that the period of sine is going to go from 2 pi to a third of 2 pi. This is going to condense the sine wave and shrink it in. And so now we're going to have 3 pi over 2 as our new period. So we are going to, I'm sorry, that's a lie. We're going to take 2 pi, our old period, and we're going to divide it by 3, so I get 2 pi over 3. What's 2 pi over 3? Well, it's going to be just a third of 2 pi. So on one hand, just to keep it simple, I'm going to try and break 0 to 2 pi into 3 equal parts. And I'm sort of just estimating here and trying to make sure that I go, 1 equal space, 2 equal space, 3 equal space. And this would be 2 pi over 3 right here. This would be 4 pi over 3. And this would be 6 pi over 3, which is 2 pi. So that means I'm going to go up and down and up right there. I'm going to repeat it. I'm going to go up and down and up. 1, 2. All right. So something like that. Obviously not the best graph in the world, but that's what we've got. So we have shrunk the graph of sine and shrunk it down. And what you'll notice is we've created 3 full periods where sine did 1 period before. We've broken that period into 3 parts. That means we'll get 3 full rotations within one. All right, so just keep all that in mind. It helps to have the context of that to kind of see what's going on here. All right, but besides that, let's go back to solving this question. So we know that with algebra, we kind of need to get rid of the outer function first. And the outer function on this one is sine. So we're going to take the arc sine of both sides, which simply gives us 3x equals the arc sine of 1. And honestly, we're going to stop right there. So we're just going to pause right here. And now we're going to think about what the answer to this is. I know this is 3x. We're going to come back to the 3 in a minute. We've got to answer this question first. So what is the arc sine of 1? So again, we think about our circle. When is sine 1? Its sine is 1 right here, only one place, and that's happening at pi over 2 and every circle thereafter. So I'm going to leave it as 3x equals, I know the answer is pi over 2 plus 2 pi n. But that's not our answer because that's the answer to like x equals, right? If we didn't have that 3 on it, we'd be done. But we do have that 3. So what's our final step now that we know what the right side equals? Now we just divide everything by 3, which gives us x equals pi over 6 plus 2 pi over 3 n. For every n that belongs to the integers. All right, so how does this make sense? Well, we took what we said was the answer was, let's go back up here to green, right? So we said the answer was going to be pi over 2, and then we'd have to go all the way around a circle again to get pi over 2 again. But now we have in fact shrunk this down. So what happened to pi over 2? It moved to pi over 6. A third of pi over 2 is pi over 6. So now we're sitting right here. And then we just go all the way around one rotation. But remember, one rotation is going to happen a lot quicker. It's going to be all the way back up to the top in 2 pi over 3. So we're simply going to add 2 pi over 3 and we're back up at the top. We're going to add 2 pi over 3 and we're back at the top. So in fact, we get 3 answers between 0 and 2 pi instead of the one answer that we would have normally thought of. Why? Because we rotate around the circle essentially faster. So 3 times around the circle in the same time it would have taken us 1 time before. All right. Hopefully that makes sense. The context of what's going on helps understand, but notice I didn't really need the graph to answer the question. I just found my answer and then I divided by 3 at the end and I was done. All right, let's take a look at B, see if it's similar. Again, we have sine of a thing plus sine squared of a thing. So when I'm looking at this, I think it's obvious to me at least that I can factor out sine of x over 2. They both have one of those. Once I do, I'm left with 1 plus sine of x over 2. So I have factors equal to 0. So that means either sine of x over 2 has to equal 0 or 1 plus sine of x over 2 has to equal 0. Again, I'm not going to worry about the x over 2 for now. I'm going to dissolve the sine, make sine go away. So what does that? Arc sine. So I take the arc sine of both sides, leaving me x over 2 equals the arc sine of 0. I'm going to subtract 1. And then I'm going to take the arc sine, leaving me with x over 2 equals the arc sine of -1. So now I need to answer these questions. So I'm going to pause and ignore the x over 2 and just answer them like I have been doing. Draw a circle. Arc sine, I don't know why I keep doing this. Arc sine of 0, not theta. What is the arc sine of 0? What angle has a sine of 0? That would be my good friend x over 2 equals. I can say this in one statement. At 0 plus pi or just pi n. Okay, and I'll do the stamp on the end in a minute. Or x over 2 equals when is arc sine negative, what's the arc sine of -1? So what angle has a sine of -1? That would be either 3 pi over 2 or negative pi over 2. It doesn't matter which one. I'm guessing most of us probably would have put 3 pi over 2. I'll go ahead and do the same. And then wrap around the circle 2 pi times. Right? All the way around, all the way around. There we go. So those are my answers. Oh, except for, gosh darn it, it's not x equals, it's x over 2 equals. So I'm going to multiply by 2. So I get x equals 2 pi n. Or x equals, multiply by 2. I get the 2's cancel, 3 pi plus, I'm sorry, there should be an n on that, 4 pi n. Now, how does this make sense? Well, you got to remember, what is x over 2 going to do to the graph of sine? It's not going to shrink it in, it's going to expand it. So now, with this graph of sine, it's going to take all the way to 4 pi to repeat. And that's why my answer ended up being around 4 pi. So I've stretched everything out by 2. So my 3 pi over 2 got stretched out. Now that's 3 pi. That's 2 of 3 pi over 2's. So everything just got wider. And so these would be my answers. All right. And let's do this next one. I'm looking at this one, and I'm seeing a quadratic. I'm essentially seeing the problem 2x squared minus x minus 1, which we know factors into 2x and x, 1 and 1. negative here, positive here, and that works. So I'm going to factor that, then I can factor this the same way. So this is going to be 2 sine of pi x plus 1 and sine of pi x minus 1. So it's just a trinomial. Do a substitution if it helps you. So then I solve this. 2 sine of pi x plus 1 equals 0. Sine of pi x minus 1 equals 0. Sine of pi x equals, subtract 1 divided by 2, I get negative 1/2. Sine of pi x equals 1. So pi over x equals the arc sine of 1. And pi over x equals the arc sine of negative 1/2. Pause, go to the circle, figure out what we're talking about. Arc sine of 1, when is sine 1? Sine is going to be 1 right here. When is sine negative 1/2? That's going to be, sine is negative in these two quadrants, and the reference angle for 1/2 is going to be pi over 6. So we're looking at pi over 6 right here, and we're looking at pi over 6 right here. So I can answer this either very creatively or not creatively, but either way, when I do this, I get answers of pi over x equals, right? So not creatively, I could say pi over x equals, and I could start at, say, pi over 2 and add 2 pi in. I could start at, let's see, this is going to be what, 7 pi over 6. And this one would be either, you could do it as a negative or you could call it 11 pi over 6. Doesn't really matter, however you want to say it. I'll go ahead and call it 11 pi over 6 plus 2 pi n. Then I divide by pi, which gives me x equals, divide by pi, I get 1/2 plus 2n. I get 7/6 plus 2n, and I get x equals 11/6 plus 2n. Okay? However, I can be more creative in a couple of ways. One way I could be creative is to notice that this angle right here and this angle right here, they're equally distant from, say, negative pi over 2. And in fact, if this is pi over 6 and this is pi over 3 away and this is pi over 3 away. So I could, if I wanted to, I could make these bottom two, I could say these more creatively by talking about how they belong to negative pi over 2. Okay? But I could even get more creative than that, and I could realize that, wait a minute, this is 90 plus pi over 6, or in other words, that's 90 plus 30, that's 120 degrees. Well, this is the same amount. This is 90 plus 30 degrees, so that's 120 degrees. This is 60 plus 60, that's 120 degrees. We could realize that, oh, they're all just 120 degrees, or 2 pi over 3 away from each other. And so I could, best answer, I could say, let's start at one of the three angles. I'm going to start at pi over 2. So pi over x equals, start at pi over 2, and then just add 2 pi over 3 repeatedly. And then to solve for x, we would divide by pi, and I would get 1/2 plus 2/3 n for every n that is an integer. Okay, so there's my best answer. All right, let's look at a couple more questions quickly. These are going to be slightly different because this time I want us to think about the answers between 0 and 2 pi. So, solve it for all x. That's what we just did. And then I want you to solve only for 0 to 2 pi. So let's see if we can get this done pretty quickly. So I'm going to jump ahead. I know I'm going to add 1 and divide by 2. So I'm already at cosine of 3x equals add 1 divided by 2 is a half. So I take the arc cosine and I get, what is the arc cosine of a half? So I go to my circle. Cosine is the x values. We're at positive a half. So we're looking at pi over 3. And we're looking at negative pi over 3. So I'm going to say 3x equals positive or negative pi over 3 plus, wrap around the circle. But now I'm going to divide by x, or by 3, excuse me, and I get positive or negative pi over 9 plus 2 pi over 3 n. So what is this talking about? Again, don't forget the 3x basically means you used to have the cosine wave doing its thing, and it took all the way to 2 pi. But now we're going to have multiple of those in the same amount. Okay. So what was going to happen at pi over 3 is now going to be squeezed by a third, 3 times closer to the axis. So it's all shrinking in. Okay, so now let's kind of set that aside. And now let's see if we can answer the question between 0 and 2 pi. And honestly, that's going to bring us all the way down to the same place right here. So equivalent, we have 3x equals, and now let's look at our circle. I don't want to talk about negative pi over 3 because negative pi over 3 is not between 0 and 2 pi. So this time I'm going to think about pi over 3, and I'm going to think about 5 pi over 3. So those are the two angles we get wrapping around the circle one time. So then I divide by 3 and I get pi over 9, and I get 5 pi over 9. Great. Those are great. Except there are more answers. These are 2 of the answers. Remember, we were looking at this before and saying, okay, how many times within once around a circle do we get the answer? And the answer was twice, pi over 3 and 5 pi over 3. But then what did we do? We shrunk it all in and brought everything closer to the y-axis, which means answers that would satisfy these angles, other coterminal angles, but bigger than 2 pi, when I divide them by 3, they're going to actually shrink in and be within the range of 0 to 2 pi. So in other words, if I look at cosine a little more carefully, and I go 1, 2, 3, 4, here's 2 pi. 1, 2, 3, 4, here's 4 pi. 1, 2, 3, 4, here's 6 pi. So cosine would look like this if I stretched it all the way out and kept going to 6 pi. And essentially at this stage, I'm asking, I'm asking when is it equal to a half, right? So if I look at the question, when is arc cosine at a half? So we got an answer of here, right? And here. So one time around the circle, we got 2 answers, pi over 3 and 5 pi over 3. If I wrapped around the circle again, then I would be now beyond 2 pi, and I'd get that answer and that answer. And then one more time around the circle, and I'd get that answer and that answer. All of these answers that are too big, were beyond 2 pi. They're all, once I divide by 3, going to find themselves between 0 and 2 pi. So long story short, I need to recognize that this is essentially, I need to go around the circle 3 times to get all my answers because of this. I don't know if I'm saying this all that well. Honestly, this is about my 5th hour of video making for the day, so I'm really eager to be done, and I think I might not be doing the greatest job. So here's the advice. Find more answers than you think will work. So just keep going. So back up here, we have pi over 3, we have 5 pi over 3. Here you said, right at this line, you said go to pi over 3 and then add a circle, right? So let's do that. Let's go to pi over 3 and let's add a circle. So adding 2 pi is 6 pi over 3. So we're going to add 6 pi over 3. So coterminal would be 7 pi over 3. So that's O being pi over 3 and then going all the way around again. That's 7 pi over 3. If I go around one more time, that's going to be 13 pi over 3. If I went around one more time, that's going to be 19 pi over 3. If I go to 5 pi over 3, that puts me here. I'm going to add to that as well. So 5 plus 6, so I'd have 11 pi over 3. Add to that would be 17 pi over 3. If I went around again, that would be 23 pi over 3. All of which in red are beyond 2 pi. So these shouldn't be my answers. But then don't forget, we're now going to divide everything by 3. So then that gets me 7 pi over 9. That is between 0 and 2 pi. I'm going to get 11 pi over 9. Oops, that was weird. 11 pi over 9. That's between 0 and 2 pi. This is 13 pi over 9. This is 17 pi over 9. Now, when are we going to stop? What's 2 pi? 18 pi over 9 is 2 pi. So this next one, that's 19 pi over 9. That's too big. So here are my answers of all of the angles that will satisfy this equation between 0 and 2 pi. So we had to go 3 times as far because we're about to divide all the answers by 3. There were 2 answers once around the circle. There's going to be 6 answers on this one. All right. I hope this is making sense. We're going to keep going and do this last problem. Unless my computer freezes. Which quite possibly might have happened. All right. Looks like we're kind of back. Okay. So ultimately, this one wants the answers just between 0 and 2 pi. But before we even worry about that, we got to get down to figure out what we're talking about here. So I have to get down to x equals. So I see that I need to get rid of the squared, and then I need to get rid of the cosine. So I'm going to take the square root of both sides. And when I do so, I need to remember that I get positive and negative. The square root of 1/4 would be 1/2. Now I got to get rid of cosine. So I'm going to take the arc cosine of positive and negative 1/2. I'm going to pause here and make my circle. Cosine is going to be 1/2 at pi over 3 and at negative pi over 3 or at 5 pi over 3. But I also want negative 1/2. So that means we're actually looking at pi over 3 in every quadrant. So once around the circle, I get an answer of pi over 3 and 2 pi over 3 and 4 pi over 3 and 5 pi over 3. If I go around beyond that, then I'm beyond 0 and 2 pi. However, I'm about to divide everything by 2, which tells me all of these angles are going to get smaller. I'm going to get pi over 6. I'm going to get 2 pi over 6. I'm going to get 4 pi over 6. I'm going to get 5 pi over 6. And in fact, those are all very small angles. Those are all under pi. So what does that mean? If I go around the circle one more time, so second time around, that's too many except for I'm going to divide them by 2, and that'll make them fit. So let's just keep going. So where am I at? Adding pi over 3. So this is adding, I'm just going to go to each of these answers, and I'm going to add 6 pi over 3, which is 2 pi. So that would be 7 pi over 3. I'm going to add, that's 8 pi over 3. And 10 pi over 3. And 11 pi over 3. So now when I divide them by 2, I get 7 pi over 6. That fits. 8 pi over 6. That fits. 10 pi over 6. Ooh, I should reduce these. And 11 pi over 6. 12 pi over 6 is 2 pi, so I'm definitely under. Let's do some reducing. This, of course, we should write as 2 pi over 3. This guy we should write as pi over 3. This guy we should write as 4 pi over 3. And this is 5 pi over 3. And those would be my answers. 4 answers once around the circle. So there's going to be 8 answers because I'm bringing that second group into the 0 to 2 pi range. Okay, I don't know if anybody stuck with me to the end of this, but if you have any questions, ask me in class.